This video goes over the classwork problems for Lesson 12 in Module 3 of the Eureka Math Grade 7-8. This is talking about lines and transversals. Okay. First off, to start with, a transversal is a line that intersects two parallel lines. Okay. If you look at line 1, it says for 1 and 2, record which angle pairs you think are congruent. Okay. Well, if we remember anything about our angles from an earlier lesson, we would know that angles, okay, angle 1 and angle 4 are congruent. Angle 2 and angle 3 are congruent because they are vertical angles. Now it also tells us angles 5 and 8 are congruent, and angle 6 and angle 7 are congruent because of vertical angles. Okay. In this instance here, I just have these ones that are the vertical angles that are congruent. There's no other angle pairs that would be congruent. Question 2 is a bit of a different story, because I have two parallel lines here. Okay, now it says I say parallel. They don't show parallel, but these are believed to be parallel because of how they are. On number 1, at some point they're going to intersect. The lines on number 2, L and M, do not appear as though they're going to intersect. So in addition to having the same, these also be part of the angle pairs that are congruent. We have some more. Okay, angle 1 and angle 5 are congruent. Angle 3 and angle 7 are congruent. Angle 2 and angle 6. Okay, and angle 4 and angle 8 are congruent. Okay, that is because they're a specific kind of angle. Okay, 1 and 8 are also congruent. So we said 1 and 5, 2 and 6, 3 and 7, 4 and 8. We also have 1 and 8. We also have 2 and 7. We also have 3 and 6 and 4 and 5. So in this case, we have 12 different pairs of congruent angle pairs. 12 congruent angle pairs, okay, in addition to the vertical angles here. Okay. And we're going to explain what these are on the next page. Okay. So when we're looking at this right here, and we have on the first one, we've got two graphs here. And if we look at both of these, we're looking at these vertical angles. Okay. So if you have angle 1 and angle 4, okay, we would say the measure of angle 1 is congruent to angle 4. Okay, again, these are vertical angles. Okay. So angle 1 is congruent to angle 4. We would say angle 5 is congruent to angle 8. We would say angle 2 is congruent to angle 3. And we would say angle 6 is congruent to angle 7. Vertical angles are created by two intersecting lines the angles share a vertex but no ray. So if we look, we have a vertex, but they do not share any sides. Okay, so when we're writing through here, we're writing down the angles, okay, and that would also apply over here with these as well. Okay, we would have angle 1 and angle 4. We would have angle 2 and angle 3. We would have angle 5 and angle 8. And we would have angle 6 and angle 7. Okay, you'll notice that some lines are marked with colors. If they have the same color, that means that we have the same angles. What you're also going to see are corresponding angles. Corresponding angles, okay, are formed when two lines are cut by a transversal, formed by a transversal intersecting two parallel lines. Okay. We're looking at angles in the same side of the transversal in the corresponding positions of each other. Okay. So angles that are on the same side of the transversal in corresponding locations. Okay. Well, what that means is angle 1 would match up and be corresponding with angle 5. So we would say angle 1 is congruent to angle 5. Okay. Angle 2 and angle 6 are in the same location in the different parts. So we would say angle 2 is congruent to angle 6. We have angle 3 and angle 7. They're in the same spot. So angle 3 is congruent to angle 7. And we have angle 4 and angle 8. So angle 4 is congruent to angle 8. Okay. Corresponding angles, it just means that they're in the same position, just in different sections of the lines. Okay. So when you have the intersection of the parallel lines by the transversal, this cuts this into two sets of 4 angles. When that happens, angles that are in the same spot, okay, on the top and bottom, or if it was side by side, angles in the same location are congruent. Okay, so angle 1 and 5, 2 and 6, 3 and 7, 4 and 8. Those are called corresponding angles. Corresponding angles. Next, we have what are called alternate interior angles. Okay. Alternate interior angles. And we have alternate exterior angles. Alternate interior angles, okay, are angles that lie in between the parallel lines on opposite sides of the transversal. Okay, so when two lines are cut by a transversal, okay, the angles on opposite sides of the transversal, but in between the parallel lines. Okay, so we have angles that are on opposite sides of the transversal, in between the parallel lines. Okay. Alternate interior angles. They're on the inside of the parallel lines. Okay, so T here is your transversal. It intersects the two parallel lines. Okay, so when we do that, we're going to create congruent angle pairs of angles 4 and 5 and angles 3 and 6. Okay, interior means inside. Alternate means we're going back and forth. So I think of it as opposite. Alternate means opposite. Okay, so opposite sides inside the parallel lines. Those are your transversals. Those have equivalent measures. So we would say that angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. Okay. Well, alternate interior angles are angles on opposite sides inside the parallel lines. Alternate exterior angles are going to be angles. It's almost the exact same definition. There's only a little bit of a difference. Angles that are on opposite sides of the transversal outside of the parallel lines. So opposite sides, so we would have one, okay, so on the other side, but outside of the parallel lines. So angle 1 is congruent to angle 8. Then we would have angle 2, because it's outside the parallel lines. That is congruent to angle 7, because that's on the opposite side of the transversal. So angle 2 and angle 7. Okay. Alternate interior means interior means inside, exterior means outside. Alternate means opposite side. Okay. So opposite sides. And the interior means inside, exterior means outside the parallel lines. That's the only difference between these here. Okay. So think kind of diagonally. The diagonal outside angles, the diagonal inside angles, those are congruent. Okay. And we're going to use this information, okay, in questions 4, 5, 6, and 7. To find some unknown angle measurements. Okay. So in this diagram, we have R intersecting N and D. Okay. So we've got to find the missing angles here. Well, we can find some of these already. If I know that this angle right here is 121, I know that the vertical angle it is also 121. I also know that the corresponding angle right here is 121. and that the alternate exterior angle of that is 121. What we have to do is find the rest of these. Now, if you remember, angles on a line add up to 180 degrees. So to figure out what this angle would be, we just need to take 180 minus 121, which would give me, I don't know why I borrowed there. That would give me 59. So if this is 59, my vertical angle is 59, my corresponding angle is 59, and the alternate exterior angle is 59. If you know one angle, and you know that you have a transversal and parallel lines, you can find the rest of the angles. Okay? Vertical angles, corresponding, alternate exterior. Again, vertical, corresponding, alternate exterior. Or we could say, hey, this is vertical, so I know that these two are the same because they're alternate interior angles. Okay, either way would work. Okay. Use your information from angles. You're going to need to know angles on a line. You're going to need to know vertical angles, corresponding, alternate interior, alternate exterior. That's how you're going to be able to find all of these measurements. Okay. Number 5, okay, we have an intersection of this line of two parallel lines, and we're going to find the remaining 7 angles. It tells me this one is 77. Well, I could say, hey, I know that alternate interior angles mean this is also 71. I know that corresponding angles make this 71, and vertical angles mean this is 71. Well, I got to find this one. Well, again, I have this. These two angles make an angle on a line. So 180 minus 71 is 109. So this is 109. Vertical angles make that 109. Alternate interior make that 109, and this would make 109 as well because either vertical, corresponding, or alternate exterior. Again, if anything else, find out what the other one is by making 180. Okay? I'm going to tell you as well. Interior angles on the same side will add up to 180 as well. And this equals 180. This equals 180. Okay? So consecutive interior angles add up to 180 whenever you have a transversal intersecting two parallel lines. Okay. Now, what's different here with number 6 is the fact that it doesn't say whether these lines are parallel or not. Okay. It does not say if these are parallel. So, what we can do is I do know that I have a vertical angle right here, which is 98 degrees. And I know that I have angles on a line here. So 180 minus 98 would give me 82. So I know that angles on a line here, and I've got vertical angles, so 82. I can find those 3 angles. Okay. I don't know what these angles are. I don't know what they are because it doesn't tell me that these are parallel lines. And if they're not parallel lines, we don't know what those angles are. Okay? Can't tell. Okay, we cannot tell. We do not know if G and W are parallel. Okay. If they're parallel, we can figure it out. But they're not telling us whether they're parallel or not. So we don't know what those angle measurements are. And to finish up, we've got equations. What do we know about these two angles right here? We know they are corresponding angles because it says parallel lines M and L. Even though there's no markings of parallel, if you look on these lines right here, see how they have these arrows? That tells me they're parallel. That doesn't say it on the lines, however, it does say parallel lines. So I know that these two angles are the same. If they're the same, that means they are equal. So I have one angle equals the other. And from here, it's using your steps to solve a two-step equation, or any equation. Okay. Add the opposite. Make a zero pair. 77 plus negative 7 is 70. Okay, instead of multiplying, we're going to divide. That's the inverse operation. Okay. 2x divided by 2. Okay. We have 1, cancels out to 1, so we have x equals 70 divided by 2, which is 35. So we have 35 degrees. Okay, x equals 35 degrees. Again, I know that because these are corresponding angles, they have the same measure. They're congruent. Okay, so this angle is congruent to this angle. If they're congruent, that means they're equal, means they're the same. So we set up an equation and solve. We set this equal to this and find x.